Hello, and welcome to the next episode of the Anti-contractor Home Podcast. I'm Chance.
And I'm Belinda.
And today we're going to talk about wood construction.
Yep. So we know that wood is one of the oldest building materials. It's not the oldest because it depends on the area people were living in. Everyone tended to use native materials. So
yeah, wood's very common in the United States.
Yes.
Because of the availability of timber.
Mm-hmm. That was something interesting. I saw that when you go to Europe, they say a lot of people who travel there, they're surprised by how few wood houses are there in Europe. They cut down their forests much early on, and they had to resort to using another source of building material, which is usually brick or masonry or stone. So even these buildings that are centuries old, they're still standing because they're made of these more durable materials. Mm-hmm. But when Europeans came to the States, they had this abundance of wood available in majority of the country. So they switched their building methods to just using wood construction.
Yeah, they didn't have the big machinery available that they had in Europe.
Yeah.
Immediately.
Yeah.
So people were just building with whatever they had, and timber was readily available.
Mm-hmm.
I know if you look at architectural history, and old St. Peter's Basilica was made of wood. A lot of old churches were made of wood.
That's true.
But they're no longer standing because they all burnt up, and so now they're made of stone.
So what about the old buildings in the States? Then they won't be standing. I know we have better fire prevention, fire protection of buildings and all that, but like 100 years from now, how many buildings will still be standing in the States?
Yeah, if you think about the big government buildings in Washington, D.C., those are all made of stone. They're big, neoclassical in nature. But there's also a stronger move towards historic preservation in today's world. So those structures may last longer because they're being preserved.
Yes. Yeah.
Still, wood will only last so long.
Yeah.
So why would you want to build a house out of wood?
Because it's cheaper.
Cheaper?
The main
material's
reason.
readily available. It's a tried and true construction method. It's easy to teach. There's nothing.
It's not too much skill involved in building a wood house.
Doesn't require too much machinery or anything. I mean, you can get a group of guys to frame out a house in no time, in a few days.
And all the houses we see are made of wood.
Especially in our area.
Yeah.
Yeah. I know in my where my parents lived, it was about 10 years ago or so, we were driving by and we saw these 3 new homes that were being constructed in Lufkin.
Okay.
These 3 new homes that were being constructed, and they used light gauge steel as the framing material.
Oh.
And
everyone was
made you wonder why would they use that? And they said, well, it's much more durable, it'll last longer, but it's got to be a lot more expensive. So when it comes to wood framing, there's generally considered 2 different types of wood framing. One is a timber frame, and one is a stick frame. Stick frame is the most common method, the one that you see apartment buildings being built of, just homes in suburbs.
So that's about 80% of all the homes in the States. They're all stick frame.
Stick frame, yeah. And so stick frame is typically uses a softwood, spruce, pine, fir, things like that. And when it comes to the actual construction of a stick frame building, you have 2x6s or 2x8s as your exterior walls. Your floor joists are 2x8s or 2x12s. Your interior walls are typically 2x4s. Your trusses are 2x4s or 2x6s, and then you have a layer of sheathing on the outside.
Wrapping up the entire building.
Yes, which is an OSB typically, 3/8 to ½ inch OSB. And whenever you're joining these together, you're using the old-fashioned technique of hammering in some nails.
So for a stick frame, how are these 2x8s attached to your foundation? I know we covered foundation in a previous podcast, but is it just screwed in, nailed in?
So your sill plate is bolted to the concrete using anchor bolts.
Okay.
So that's the basics of stick frame construction.
So I read that since the nature of stick frame means that the weight is distributed evenly over your foundation because you have studs every 16 inches. It's carrying the weight evenly. So if you have a concrete pour, you don't have to, it can just be a simple slab on grade. Your foundation can just be a simple slab on grade.
Okay. Whereas if you were using something with heavier members like timber framing.
Correct. That's a point load.
You're going to have to probably use piers for that?
You can have a slab on grade, but you have to have reinforcement wherever those timber framing members are hitting the concrete.
Okay, that makes a lot of sense.
Yeah, because that's a point load framing.
So your slab is probably going to have to be...
Footings, yeah, that's what it's called.
It's going to have footings. It's going to have to be engineered a little bit more than...
a simple...
for stick frame. And so that goes back to why people use stick frames, because cost. It's the cheapest, it's the easiest method to use. It's tried and true, it's simple, and it's fast.
Yes. I was looking at the history of the stick framing method in the States, and obviously timber framing, which we'll discuss in a bit, that was the earlier form of construction before stick framing. So with timber framing, you need a certain size of your tree trunks, you need larger members, but they ran out of those kind of trees in the States. So they had smaller pine trees. So they had to change their building method to these smaller 2x4s, 2x6s. And when they first started building, like in the 1900s up to the 1940s, they had really tall pine trees. So they used to have this construction method called balloon framing, where a single piece of wood would go from your foundation to your roof. If it was, mostly it was 2 stories, it never really went above that. So first story and your second story was all a single framing member.
So you'd have like a 24 or 30 foot 2x4.
Correct. But they ran out of those trees in the States. So they had to design a new method of construction, which is what's used now. It's called platform framing. So you have the studs going from your foundation to the roof of your first floor. And then there's a brick. And then you have another set of studs going from your second floor to your roof, or your third floor to your roof, depending on how many stories you have. Mm-hmm. But it's disjointed. It's not as stable as balloon framing, but since it's hard to get studs that are 20 feet long, whatever.
So it's not all one fixed piece that sort of moves in itself.
Exactly.
It's 2 separate pieces if you're doing 2 stories.
Which can move independently, more prone to cracks, but that's what they do in the States, because that's the wood that's readily available. Yeah, if you go to Home Depot or something, you can buy a bunch of 2x4s, but you can't buy 30-foot long 2x4s. Yeah. So we've talked a bit about the advantages of stick framing, why it's so widely used. It's easy, it's cheap, and wood construction is pretty sustainable, eco-friendly, because wood's a biodegradable material. But when they're making these 2x4s and 2x6s, there's a lot of waste generated.
Because they're not using the whole tree.
Yes.
And you can't. What do they do with the leftover? I'm sure they purpose it in some way.
So they use it for the engineered wood.
Oh, yeah.
They use the scraps to make engineered wood.
MDF, OSB.
Cross-laminated timber, all that stuff.
Things like that. Okay, so there's not waste.
Yeah, and then I read that they use sawdust to make paper as well.
And they use softwoods, which are rapidly renewable. Mm-hmm. So it's not bad.
Yeah, but it's also a very temporary way of building. It's not a long-term build. When you're weighing the pros and cons of like a more long-term construction method like brick or masonry or something versus wood, in the short term, it's better for the environment because you're using a biodegradable material. But if you think of it in terms of its lifespan,
because it rots and you'll have to replace members and things like that.
Exactly. It warps, it rots, and you're constantly having to maintain it. It's not as good for the environment in the long term as a masonry or brick building.
Oh, or like a steel frame where you put it up once and that's it.
Yes. But it keeps the industry going, right?
Mm-hmm.
Like all these contractors out there, they have jobs because all homes are stick frame homes.
Right.
You have foundation work, there are big cracks in your walls. You have to hire someone to fix those cracks. You just have to constantly maintain your home.
Mm-hmm. Whereas if you had a CMU or steel building, there would be less maintenance required.
And we also have to think about the quality of these 2x4s that you get. If you go to Home Depot or wherever else you're buying 2x4s from and you bring all these 2x4s to your site, many of them now are not going to be usable. because they're warped, they've got knots, they're
I would
brittle.
say 95% of them are warped to some extent, but some are warped worse than others to the point where you can't even use them.
Exactly. So you just have to dispose of those. Yeah, you're creating more construction waste.
So in a terms of low maintenance, stick frame may not be the most optimal construction method for an anti-contractor home.
Yeah.
Because you'll have to constantly maintain it. But in our house, which is 50 to 60 years old.
It's still standing, but none of the walls are straight.
No, none of the walls are straight. And I mean, do we blame that on the lumber itself, or do we blame that on
The people who constructed it? Well, when we opened up some of the walls to replace drywall and everything, we could see the studs weren't sitting perpendicular because they were warped. So there's only so much the people who are building the house can do.
Right. You can't get straight walls anywhere.
Yeah.
Especially with wood, because it shifts and it moves. And we've made some furniture out of wood as well. And we know we've had a lot of experience with how it moves over time.
There's a term called creep. It's the natural tendency of materials to warp and move and shift over time. But steel is not a natural material. I mean, it comes from iron ore, which is natural, but it's been manipulated to create a man-made form with the I-beams, so that doesn't creep over time. Timber framing and stick framing naturally creep.
So the other wood framing construction method is called timber frame. And this consists of large, for example, 12 by 12 columns and beams that are used throughout the house. Now, there's not going to be near as many of those as there are when you're using 2x4s for your stick frame. And so this allows for bigger open spaces, and the joinery is different as well.
So the joinery is mainly mortise and tenon. It's more elegant. People like to expose the timber framing. So it used to be just pegs. That's the original way they used to build.
So a timber frame is probably...
It's older.
Yeah, it's the old construction technique that you would see.
Like Netherlands.
Yeah, in things like St. Peter's Basilica, the old St. Peter's Basilica.
So nowadays it's made by machines and not by humans, and the joints are more standardized mortise and tenon joints. It's an engineered system. It's something mostly done off-site and then brought to the site.
The actual assembly of this timber frame could be much quicker than a stick frame.
Yes.
Because you're just slotting things in place and it's done. Mm-hmm. But at the end, all you have is a big open frame.
Which is what you'd have at the stick frame house, too.
But with a stick frame house, you have your windows framed out, your doors framed out, things like that. With a timber frame, you're not going to use that large timber to frame out your doors and windows. So would you have to use stick frame within your timber frame in order to frame out your windows and doors?
So people talk a lot about the cost of timber framing, how much more expensive it is. But you can actually, like what you said, use a hybrid system. The main structure is just a timber frame, a very simple timber frame. But then when you want to frame out interior walls or windows or something like that, then you use a stick frame with it to lower the overall cost of your house.
How would you do that otherwise?
Well, your SIP system, which is what's your exterior sheathing plus your insulation, that has holes cut into it.
That would be how you frame out your house.
That's how you frame out your windows.
Okay.
Yeah. And then you just waterproof the exposed insulation and you slot your windows in there into the SIPs.
So going back to stick frame, when it comes to insulating your house, the most common method used is to put Batt insulation in between your studs.
Or spray foam or whatever insulation you choose to use.
Yeah.
Or denim.
I think the cheapest method is the Batt insulation, which is going to be most commonly used. But there are other forms of insulation, which we'll talk about in another episode. When it comes to insulating a timber frame house, the most common method is to use SIPs, or structurally insulated panels, because you don't have those interior studs to frame in between.
Yes.
So you need some way to enclose your open frame. And so these structurally insulated panels are 2 sheets of OSB on the outside and a polystyrene on the inside. And so that encloses your timber frame and seals your house. So some argue that form of insulation is better than just putting insulation in between your studs, because you have that that thermal break at each stud, whereas SIPs on the outside of your timber frame, there is no thermal break. So we talked about a few of the pros for timber frames as quicker installation on site, quicker assembly.
Yeah.
It's fewer pieces. We talked about the use of SIPs and how that can be a fast construction method as well. What are some other pros of using a timber frame?
It has better seismic tolerance, which is not as big of a deal where we are living, but in certain areas like California or something, it could be a better method of construction. That's mainly because it has larger members. It's a single system that can move as opposed to smaller studs that can move independently. And then it has better thermal performance because usually these walls are thicker. But that also depends on the method of construction. You could make it with thin walls.
So
but,
the walls as in the SIPs?
if you're enclosing the timber frame too, you could have really thick walls.
Mm-hmm. That would be very thick.
Yeah, and that
But
has...
then you're going back to having that hybrid system because you got to
Frame
enclose
that
those
out.
walls somehow.
I saw that if you use like mineral wool insulation or something, you could have better noise and sound insulation between your floors and also from the inside to the outside.
Yeah, isn't
Stick.
that just floor joist the same that
Yes.
it would be with a stick frame?
I wonder if you can use thicker, if it's just timber framing.
If you had your timber frame framed out for a second story, you could use prefab concrete panels,
Just set it on there.
perhaps.
Yeah.
The main negative with timber frame is the cost. There's no way of getting around it. It's more expensive than a stick frame. It's customized lumber, especially if you're not using some sort of Glulam system. If it's actual timber solid wood coming from a tree.
And you can find like a pine timber frame system, but from what I've seen, it's mainly like Douglas fir, hemlock, or oak or cedar. Those are the materials they use.
But even though Douglas fir is a softwood, it's very dense. So it's much more expensive.
So I was looking up how you could reduce the cost of timber frame housing. And whenever you look for timber frame houses online, they try to sell you these kits, timber frame kits, Glulam or cross-laminated timber.
Is that like
kits.
a DIY kit?
Yes, kind of like a DIY kit.
Sounds expensive to ship.
Yeah. But that's where your increased cost is. So if you really want a timber frame house, there are websites out there that recommend that you come up with your own design and go to a timber frame manufacturer. And I don't know how that would be cheaper, but when it's not a pre-made kit, you could reduce the cost of your home.
Is that because you have the flexibility with your own custom design to do it any way you want? And with those kits, you're restricted and there's a temptation to go outside of what's allowed. And so you may have to buy like two of those kits in order to make up this one house that you want.
Maybe.
I don't know.
Because you'd think that a custom would actually be more expensive than a kit. But they're saying if you just get the individual members, just get the members and not try to get the entire kit, you could lower the cost of your timber frame house.
And then you could notch out the mortise and tenons yourself, right?
Yeah. The big advantage of timber frame is the lower uncertainty. Like when you're coming to the site, you have all these members that are already like prefab in a factory. They know it goes together. So when it comes on site, you know it's going to work. There's less uncertainty, quicker turnaround. When it's a stick frame, there's so much that can go wrong in your construction.
There's less margin for error, perhaps?
Less margin for error.
It's like putting together a puzzle, whereas when you're doing stick frame, you're
cutting the puzzle.
Made as you go. I mean, you may have those warped members that cause a wall to veer a little bit one direction or the other and then shorten this other wall. Yeah, you have to compromise from there.
I'm sure if you ask someone who does stick builds, they say, no, there is no uncertainty.
If you're into timber frame,
they have their own mindset and say
right.
that's the best thing you can do.
This is why it's so much better.
Yeah.
And so we're trying to look at it from a non-biased perspective.
Yeah. And they also say like timber frame is less prone to infestation by termites and all that.
That's because the SIPs are on the outside of the house. Protecting your timber is further inside and thus further away from
moisture,
potential termites.
Yeah.
But don't you have OSB in your SIPs, which could attract termites as well?
Yeah. But they say if you keep the moisture content of your timber frame house below 20%, then there's zero chance of it being infested.
Termites are not a big issue in our area, so that's not
Yeah.
a big concern of ours. But
Yeah. So you just talked about OSB and on the SIPs, and that's the other disadvantage of a timber frame house. Whatever sheathing you have on your house, that's just nailed into OSB. There are no 2x4s or anything to nail them into.
what sheathing?
Like paneling.
Okay.
Whatever
you're finishing out your
any exterior finish, yeah, that's all just nailed into OSB. And we've dealt with OSB. Not the best material.
Yeah.
They say it has strong structural strength.
Yeah.
It can hold it, and
It's not good for furniture.
Yes.
It has its uses for exterior sheathing, I would say.
Yeah.
But that's what if you were to face your house with a brick veneer, it would be on top of that OSB.
Yeah. There would be an air gap,
Which is what a stick frame house is too, right?
but I guess you can also nail it into the 2x6s or something every couple of inches.
True. Yeah.
Every 24 inches.
Mm-hmm.
You could nail into that. So R values, that's pretty important. So with a timber frame house, it's completely cladded with this SIP system on the outside, your R value would be the R value of your SIPs.
Right.
Unless you use an additional insulation on the inside, like batt insulation, mineral wool, whatever. But just SIPs has an R value of 5. So the most commonly used SIPs is a 1-inch EPS foam with OSB on either side, and that is a 3.8 R value.
Your SIP is 2 inches thick?
Yes.
Wow. I thought SIPs would be like 5
much,
or 6
much.
inches.
So
yeah.
the stuff that we've seen on Grand Designs, that's really solid. So that's how you increase your R value, by going thicker.
Yeah, the thicker your polystyrene, the higher your R value will be.
So the second most popular SIP system used is a 1-inch polyurethane foam, which has, with OSB on either side, which has a R value of 5. Your polyurethane foam has a higher R value than EPS.
It's a more dense foam.
And I know that's a very, very thin SIP, so you can get thicker. But if you have a simple 2x6 house with batt insulation, you have an R value of 14.
Okay, so how thick would your SIP have to be to match that 14
I don't know.
R
This
value?
is why you have to do some research.
I was thinking if we could just take that, well, you would have to consider the R value of the OSB as well. Yeah. But for simplicity's sake, if you tripled that, you would have like a 3-inch polyurethane insulation with 1/2-inch OSB on either side.
That would get you an R value of 15.
Which is a 5-inch thick wall. And comparing that to a 2x6, which is 5.5 inches.
Which is comfortable then, yeah.
Yeah, so they're very similar. But a 2x6 with batt insulation in between is much less expensive than a SIP panel.
So whenever you use SIPs, it's on the outside of your house. So it's increasing the exterior footprint. And people say that whenever they calculate taxes for your house, they calculate it based on the exterior footprint. So you're increasing the taxes of your house if you're using like a 3-inch or a 4-inch SIPs, versus if you use a 2x6, you're building to the inside of your house and you're adding insulation on the inside, so you're reducing your taxes.
You're also reducing the size of your house.
Yeah.
That's interesting.
Yeah. But it is more airtight than a stick-built house.
Using SIPs.
Using SIPs makes your home more airtight. And I saw, you see Energy Star ratings for buildings.
Yeah, good old 1993 standard.
1993 standard?
I believe.
Oh, wow.
When it was formed, yeah.
So all SIPs homes are automatically qualified as a low-energy home if you use that.
If you use 100% SIPs or
100%
if you use
SIPs.
one SIP.
Yeah.
Can I use one SIP?
And so these SIPs can also come with a drywall on one side attached to the OSB. So you immediately finish your...
Oh, wow.
Can come prefab with that. Makes things
I
easier.
can see a lot of good and bad with that.
Why?
The bad is you have to use drywall.
Yeah.
So we've been talking about timber frame and engineered wood using OSB for your SIPs. But let's get back to the actual structure of the timber frame. And we mentioned how expensive it can be because you have to use a solid piece of wood. Well, there are techniques that can lower your cost by using stock lumber like 2x4s, 2x6s, and laminating those together to create what are called Glulam beams. So these glulam beams, this glulam timber, can be fashioned with these mortise and tenon joints and used just the same way that a typical solid wood timber frame can be used. It's just a little bit cheaper because you're using a readily available wood. And an advantage of that is that you can do things like laminate these members in curves or something and bend to shapes you may like if you were to have some sort of radial wall or something.
Or arches in your ceiling.
Yeah, or a vaulted,
Yeah.
a barrel vaulted ceiling. There's also other types of engineered wood. We mentioned OSB, so there's this type called parallel strand lumber, which is basically just OSB formed into a big timber frame.
Actually, laminated strand lumber, which is the cheapest engineered wood, that looks a little more similar to OSB. Parallel strand lumber is more expensive than laminated strand lumber.
Okay, which is basically just
Thick OSB.
OSB.
Yeah.
Yeah, big OSB.
But what's becoming really popular now is cross-laminated timber. And they have lots of CLT prefab houses available online and in the market. So it's like Glulam, except that every other lamination is perpendicular to the one below it. So it's cross-laminated. It's stronger. And like wood has a very directional strength. So by laminating it perpendicular, you're increasing the strength of the wood.
So kind of like if you're making a tabletop and you have your grain going in, the arc is going in one direction on one piece, and then you want to rotate it 180, so it's going in the other direction. So you're sort of balancing out and you're creating a stronger tabletop.
Yes.
That's interesting. So that's a way that you could reduce the cost of your timber frame, but it's still, at the end of the day, it's going to be much more expensive than a stick frame house.
And engineered wood is expensive. It's not cheap because it has to be put under extreme pressure for these to come together. And even if you're using like bits and pieces to make up a laminated strand lumber, parallel strand lumber, you're still using glue, still using pressure. It's treated, and it's
more labor intensive. The initial process.
I wish it were as cheap as.
I wish there was something that was as cheap as stick frame.
Stick framing,
because we've seen it so much that we're sick of it. We've seen the pros and the cons of it, and we would like the aesthetics of a timber frame, but with the cost of a stick frame.
Yeah.
Is there another solution out there?
So maybe what we could look into is using like that blue colored wood, the ones that we've seen in some of the tabletops and like the pallet wood stuff that we've made that has these blue grain in it. So that's wood that has been infested by the mountain pine beetle. So
okay, yeah, I've seen that oftentimes whenever we're cutting down, like when we used to break down pallets or something, you would see this. You'd get a couple of things. You would get the smell of the sap in the wood sometimes, and then you would get these what look like blue streaks or lines in your wood, and so that's the beetle infection.
Yes,
but that's not affecting the integrity of the wood?
It doesn't, no. So these pine beetles are not like termites. Termites actually consume the wood, eat it up, and affect the structural integrity. But the pine beetles just live off the nutrients, and it gives this blue color to the wood.
So why do they cut all the trees down if it doesn't affect
because it's going to spread to all the... It's still not a healthy tree.
Okay.
It's consuming all the sap of the tree. It's going to kill it, but it's not affecting the integrity of the tree.
So if they catch it within a certain time, they can still use it as stock lumber?
Yes. Yeah. So they use it for log homes and custom homes, and it's not shown any structural defects in the wood.
Okay.
So if we can somehow find cheap blue wood and make a timber frame home out of that, I don't know.
This sort of leads into our podcast we're going to talk about next week, but I'm interested in how wood is rapidly renewable, at least softwood is, and doing a stick frame or timber frame home is very environmentally friendly.
Yes.
But I've also seen that if you were to do a steel frame house, steel is 100% recyclable. I don't see that being any worse than doing a stick frame or timber frame house.
I think it goes back to the initial carbon emissions.
The energy
Yeah.
used to
Produce,
make the steel.
Yes. So that is much higher than making a 2x4, 2x6 home, the initial carbon emissions. But like we talked about in the beginning of the podcast, and this is kind of going full circle, you have to take into account the lifespan of these structures, the maintenance of the structures. You can't just look at the initial carbon emissions.
Yeah, you can't look at the initial energy expended. Just take that factor into account whenever you have to think about the whole life cycle of the house.
Yeah. If it's going to be used for 100 years or something, and you're barely doing anything to it, to the house, it's standing by itself.
And at the end, the steel frame can still be recycled 100%.
Yeah.
Maybe it's a little better than a stick frame.
Yeah.
But that's something we'll discuss next week in next week's podcast when we look at steel frame houses.
Because we like those over wood.
We think we like those.
We think they like.
We'll look into that a little bit more, but I hope you enjoyed our dive into stick frame and timber frame homes, and join us next time on the Anti-Contractor Home podcast. Thanks.
Bye for now.
Bye.